In example 2, we need to find and verify the inverse for z of x is equal to x squared. Then we'll state the domain and range for the inverse. Let's do the find part. I'll show you how to do the verify part, and then we'll work with this domain and range piece. So to find the inverse, what I like to do is take this function notation out and just write it as y is equal to x squared. Now the inverse of this function, which is still z of x here, is all we're going to do is we're just going to change the positions of the x and the y. So wherever we see a y, that's going to be an x. And wherever we see an x, that's going to be a y. So this is z of x right here. And this is the inverse of z of x. We've done something. We've changed the x's and the y's. What we want to do now is try to solve for y. You'll note that to solve for y here, we just need to square root each side. I'm going to change this right position to the left, and then we absolutely need to write the plus or minus here in front. When you are the one doing the square rooting, if it's not a radius or a side of a triangle or something like that, you must put the plus or minus sign there. This y is now the inverse of z of x. We want to try to use that notation. I prefer doing it with y. It helps me see what's going on, and I only have one variable. And this is one variable also, but it does look like it has two there. So it can get a little tricky if you try to leave the z of x in. So we've now done this part. We've done the find part. So this is part of our answer right here. I'm going to verify this, and how we verify this is we compose these functions. So let me write down z of x here for you. And I'm going to do that in green. I hope these colors make it a little bit easier for you to see what's happening. And then we'll do the inverse of z of x, which is plus or minus the square root of x. And what we're going to do is we're going to do a composition of functions. So we're going to try z of, and then this is going to be z of the inverse of z of x. And then what we're also going to do, hope I can squeeze this in over here. Well, let's do that maybe down here. So we're going to do the inverse of z of x. So let's see how this works. Let's do the first one together. So we've got z of x, which is x squared. And anywhere we see the x here, we're going to replace it with this entire function. So wherever that x is, we're going to take that x out, and we're going to replace it with plus or minus the square root of x. The one down here is very similar, but this time we're going to start with this function, and then instead of the x, there's going to be z of x here. So this is going to be x squared. Let's work with the first one. And after we've done that, I'll just change colors on you, and maybe we'll just verify that here in black. So we have plus or minus the square root of x being squared. Now the square root and squaring are inverse operations. They'll cancel each other out. And so what we're essentially left with is just x. If we look at the right hand side, we've got the square root of x squared. And the square root of x squared is also just x. So let me write this down for you. If two equations are, squeeze it over a little bit here for you. If two equations are inverses, when you compose them, so that's what this process is, it's a composition of functions. When you compose them, you will get just x. If you get anything other than x, then either you compose them improperly, that's possible, or they just aren't inverses of each other. We now want to state the domain and range for the inverse. And so if you remember, we just did a quick sketch of this thing. The inverse of z of x here is just plus or minus the square root of x. And it's going to look something like this. And you could use your graphing calculator if you wanted to. You'd actually have to enter this in twice into your calculator. There's a way to do it in one line, but you could just do y sub 1 being square root of x and y sub 2 being negative root x. And you'll find that it's going to look like this. Notice how the original function was x squared would look like this. Inverses are going to be symmetric over that line y is equal to x right here. So there's your line y is equal to x, and inverses graphically are going to be symmetric over that line. But we really care about for this one the orange graph here, which is the inverse. Maybe I should have done that in red. That is just what we're needing to find the domain and range of here. So we'll try to make it red. That's what color we used over here. There you go. So the domain are all the possible values of x. You'll notice from left to right, the first value that's possible is 0. So the domain is going to be 0, and then it goes all the way to the right. So all the numbers to infinity are possible. For the range, this graph would begin way down here. It continues to go negative, and then it continues to go positive here. And so the domain is all real numbers, or negative infinity to infinity. So we've got the stuff in brown here is the find part. The verify part is the holiday colors here. And then the domain and range are going to be right down here.